This section of the Six Sigma demo room will look at cooling the virtual facility. In the Errors tab, it states that there's insufficient cooling within the facility to maintain the equipment we've installed in the room. We'll now address this by adding cooling units. The ACU provides cooling for the equipment within the virtual facility. We'll eventually have 10 ACUs within this particular room. Like other entities within the room, ACUs have geometry and placement properties, as well as display options and simulation results. The first ACU will be placed on the back wall at the left of the room, so under the placement field in the dialog box we'll enter the relevant X and Z location data. There are also two properties that are exclusive to ACUs, cooling and ACU status. The cooling properties influence how the ACU operates in the virtual facility. The maximum cooling capacity dictates how much cooling can be achieved. The ACU status property enables the user to quickly turn off the cooling and or the fans. The amount of air supplied is determined by the ACU supply vent. A variety of flow devices can be specified depending on the type of fan in operation. The uniform flow supply provides a constant flow rate across the whole face of the vent. The swirling fan and the blower augment the manner in which the flow leaves the supply vent. The radial fan alters the geometry of the supply vent and provides a graphical representation of a plug fan. All of the fan types have fixed flow rate, curve or controlled options. If a fixed flow rate is employed, the amount of air leaving the ACU is constant during operation. The curve parameter utilises a pressure-dependent flow rate that you can specify from manufacturer's data or your own information. Controllers represent the control system that take inputs from sensors and are important when specifying how the ACU will behave with regard to the control temperature that the unit aims for. The attached sensors can be placed anywhere in the virtual facility and can be linked to either the supply or return side of the unit. Selecting the ACU, we can see a number of additional features in the menu bar. These include adding additional vents to the unit, custom solid obstructions and scoops. Pre-constructed ACUs can be taken from the Six Sigma library and used in the virtual facility. These units have been modelled according to manufacturer's specifications and quality controlled to ensure accuracy. We'll now replace the existing default ACU with a pre-modelled unit. This is easily done by right-clicking on the ACU either in the room or in the model tree and selecting Replace. A window containing the available libraries will pop up on the screen. From the Six Sigma library, we'll select an ACU, then click OK. You'll see that the default ACU has now been replaced. You can create an identical ACU by copying this one and pasting it into the model tree. We may see a collision error as the two ACUs are now occupying the same space in the virtual facility. If we select the new ACU and right-click on the right-hand blue manipulator, a Move By window will now appear on the screen. To add more ACUs quickly, we'll use the Pattern tool. We'll now put another two ACUs on the back wall using this method, which will be equally spaced. We'll enter the X pitch and number in X. The final ACU on this wall can be copied from an existing ACU and pasted into the virtual facility. The remaining ACUs are to be placed on the opposite wall so that they face the current ACUs in the room. We'll select all 5 ACUs from the model tree, then copy and paste them into the virtual facility. There should now be 10 ACUs in the model tree. The 5 selected units need to be placed at the bottom of the facility, so we'll change the Z location and orientation. The units are now on the opposite wall facing into the room. Finally, with the bottom ACUs still selected, we can right-click on the furthest right blue manipulator and move the units into a suitable place. Now that the ACUs have been added to the virtual facility, we can assess what type of impact they might have by looking at the room summary. We can access it by clicking View, Add View, Room Summary. This new tab outlines the key data for the virtual facility, including the amount of cooling that is available and the airflow from the ACUs. This summary tab becomes even more useful once the virtual facility simulation is complete. You'll notice that the effectiveness fields remain empty in the room summary. These indices measure how effectively the cooling system supply air is supplied to the equipment and how effectively the hot air is returned to the cooling system. To turn on effectiveness indices, access the solution control from the model tree and expand the additional analysis and effectiveness indices fields from the property sheet. Then simply change the active field from no to yes. Enabling this option will allow supply and return effectiveness calculations for the ACUs, cabinets and equipment within the virtual facility and give a numerical indication of the cooling system performance. Cooling in the virtual facility is not limited only to ACUs. It's also possible to simulate air flowing into and out of the room through cooling vents. We'll now add some vents to the walls to simulate an external air source in the virtual facility by selecting the right side wall from the model tree and clicking to add a new cooling vent. The characteristics of the vent are easily changed. Much like the supply vents of the ACUs, the flow device can be changed to augment the flow pattern that is created by the air leaving the vent. There are two options for specifying how cooling vents behave within the virtual facility: attaching the vent to an ACU or manually inputting the flow rate and air temperature. Linking the vent to an ACU is useful if the unit is located externally, whereas manually inputting the cooling specification would allow simulation of a fresh air supply. Verifying the model will show that there's now a thermal modelling error, as more air is being supplied to the facility than is being extracted. A return vent is required to facilitate removal of the excess air. We'll now select the left side wall from the model tree and create a new return vent, which we can customise so that it faces the supply vent on the opposite wall. We'll also set the geometry of this vent to match the supply vent. The construction of a vent can be modified. You can choose whether it's completely open, perforated, slotted or mesh. You can add further specification such as the shape and size of perforations and the total percentage of open area for airflow. Once again, this return vent can be attached to an ACU if required. There's also the option to attach it to an external environment, which specifies that the flow through the vent is dependent on the flow rate of the air in the surrounding area. Verifying the case once again now shows that the thermal modelling error has been resolved. It's also possible to see the effects of an ACU failure on the thermal profile of the room. This is a powerful tool, as it's the only reliable way to determine how the equipment within the room responds to an unexpected cooling failure. Selecting Analyse Cooling Failure from the Tools menu brings up a dialog box with two tabs. The Time Control tab contains the fields which influence how the transient solution will run and at which time interval the results will be created. From the Failure Scenario tab, we can see how the cooling system responds to a failure, whether it's an individual ACU or the entire chilled water system that malfunctions. This concludes the cooling part of the demonstration.